got our enemy able to move around nicely. We can make him move in a straight line, we can make him move diagonally, or we can make him move diagonally up and move basically in those kind of rigid straight line directions. But let's give him a little bit more variety and give him the ability to kind of change direction when he's after reaching a certain point on the screen. So we're going to create a new movement script for our enemy here. And before we do that, I'm actually going to remove the current script that he has attached to him. So I'm going to remove this basic movement script by clicking on the little gear in the top right and then selecting remove component. And then we're going to go into our scripts folder and we're going to create a new C# script that we're going to call, we'll just call it enemy movement. So it's a slightly more advanced enemy movement, not just basic anymore. But it's still not going to be too complicated for us to move around in. Once it's loaded up here, first thing we're going to want to do is we want to make sure that we still make it so that our enemies are destroyed when they leave the screen. So we're going to keep the same void on became invisible that we had before, and we're going to say as soon as our enemies become invisible, we want them to be destroyed, not destroy over time, we want to just destroy them. So destroy game object, like that. So perfect, that's what we want that to do. And the next thing we want to do is talk about how our enemies are going to move. Well, first of all, we'll give them a certain move speed, because no matter what, they have a value that they're going to use to move to the side. So we're going to say public float move speed, but again we're going to have a move speed X, and we're going to have a public float for move speed Y. Now we're not just going to have it so that our enemies can move to the left and also move down at the same time. What we're going to do is have it so that our enemies move to the left to a certain point, then they can either move up the screen or move down the screen, and they'll start moving in that direction. So say we'll wait till they get 5 units into the screen, and then we'll tell them, okay, at this point move down, and then they'll start moving downwards as well as to the left. So to do that, we're going to take advantage of using switch cases, which are something we haven't encountered yet at all, but are very simple and very easy to use. But of course, if we're going to be moving our objects around the world, we want them to have the rigid body that makes them move around. As previously we used in our basic move script, we used our velocity to move. We're still going to use that on our enemy movement here. So we're going to have a private rigid body 2D that we'll call the RB, and in our start function we'll make sure and we'll get that functionality, or we'll get that rigid body, sorry. We'll get the rigid body equals get component rigid body 2D. So perfect, we got our rigid body set up there. One other thing we're going to need to know is how far in are we going to move before we are deciding whether to move up and down. So we'll use a value to establish that. We'll say public float Y target. So this will be a Y position on the screen. No, actually this should be X target, sorry, not Y target. This will be an X position on the screen. So if we just pop back into the game here, say we'll set it to be at this position here, which would be at the value 3, which will be, we have 0 at the center, and then 1, 2, 3 is here. So say once the ships travel into this point, then they'll start moving down the screen there. So we want to use a variable that will decide which movement type our enemies are going to use. We could want them to move up once they reach a certain point and just keep going up, or we could want them to move down once they reach a certain point and just keep going down, or we might want them to go to a certain position on the screen. So say if they start at the top of the screen, we might want them to move towards the bottom of the screen, but then instead of just going completely off, they'll stay there and just stay at that level while they move off to the left of the screen. Or we could have them start at the bottom and move all the way up to a certain position near the top and keep traveling to the left that way. So to do that, we're going to have a certain amount of movement types, and to keep track of it, we'll just create a public int that we'll call move type, like this. And we're going to keep track of what we want our move types to be. So we'll say here we're going to add a comment just after this. So we type // and that means anything else we type on this line won't appear to the computer. It won't recognize anything else we type here. So we're just going to say // and we're just going to write and say to ourselves 0 will be for moving up at X target. 1 will be for moving down at X target. And then 2 will be for moving to a point. So we're going to have it move towards a certain position on the y-axis. We're not going to set that up just yet with any references here. We'll return to that in a little bit. So we'll set up these first two simpler cases first. So as I said, to handle this, we're going to use a thing called a switch case. And a switch case basically works on, it takes in a value, or a variable, which in our case is going to be this move type variable, and it checks and sees if it's equal to any particular cases. So for example, we're going to check and see if move type is equal to 0, and if move type is equal to 1, and if move type is equal to 2. So to do that, in our update loop here, we're going to say switch, and then in a bracket we're going to type move type, because we're using a switch and we're wanting to check it against the move type variable, which is what we're using here. And then below that we're just going to type our curly brackets here like this, and then in the space in between we're going to type here case 0. So what we're saying is, if our public int move type is set to be 0, then we're going to use this movement type, so moving up at X target. So here we would type in a bunch of code to do our movement. And actually we'll go ahead and do that before we look at our other cases at all. So in our case 0 situation, we know we're going to start moving up once we reach the X target. So the first thing we need to do is see if our enemy object has reached the X target value yet. So we'll say if our transform dot position dot x, if that is less than what our X target is. And the reason we check if it's less than is because, remember, our objects are moving from the right of the screen and moving to the left, so the X position of it is getting lower and lower, and we want to check if it gets lower than whatever our X target is at this particular point in space, say, and then it keeps going. So if our transform position is lower than our X target, then we know at that point we should be starting to move downwards. So we can say, okay, in that case, then our rigid body dot velocity should be set to equal to a new vector 2 that on the x-axis we'll be moving at our move speed x. So we'll say move speed x, and on our y-axis we'll be moving at whatever our move speed y is. So we'll say move speed y. Now we'll just close that little bracket and put our semicolon. But before we move any further, so our move speed x and our move speed y, we're only really going to want to put a positive value into them in our inspector. And that's because our move speed y will change depending on whether we are moving up at X target or moving down at X target. So we want to make sure that no matter what, we're going to put in the same move speed y here. And basically, if we're going to move down, we'll change it so that our move speed y will here be minus. But if we're going to move up, we'll put it to be positive. And we might as well, to make sure that we maintain that and that there's no confusion within it, we want to make sure that our move speed x can just be put in as a positive value as well. So no matter what, we always want to have a minus velocity then. So we'll say minus move speed x and minus move speed y. So if our transform position is below our X target, then we'll start moving down. Otherwise, we want to set our rigid body velocity to be equal to a new vector 2 that is going at minus move speed x. So we're traveling along on the x-axis, but on the y-axis we don't want it to be moving at all. So we'll say 0 and we'll hit our semicolon. So let's just test this out before we go any further with our movement script. So we'll save that. We'll go back into our game. Compile. Oh, we've got a bit of an error. Of course we do, because there's one thing you have to write at the end of our switch statements. So at the end of every one of these individual cases, we want to type the line break. And what that means is it knows that this is the end of the switch, so we can get out of this and move on to doing other things if we have anything else in our update loop. Otherwise, it just moves on to the next update loop. So we'll just save this again, go back in here, let it compile, and once it's finished spinning in the corner, there we go. We'll go to our enemy, we'll give him the enemy movement script we just created. So our move speed X, we'll set that to be, say, we'll give him a movement speed of 5, or we'll stick with 3 actually. We'll set the Y movement speed to be 2. Our X target, for the point at which we'll start moving down, we'll set that to be 2, say. So at this point, kind of when he reaches nearly the middle of the screen, it'll start moving down. So we'll set our X target to be 2. And our move type we'll leave at 0 because we know that's the one we want where our enemy ship starts moving downwards. Okay, so let's test this out now by playing the game. So we see our ship starts going, and then at this point he starts moving down. So perfect. Now it's adding a little bit of variety into the game. Maybe we'll make him move a little bit faster because he's kind of not finished moving down by the time he gets to the edge of the screen here. So we'll just say move speed down. Let's move him at 4. So it's a bit more extreme and a bit more of a challenge to the player. So imagine if you had multiple enemies doing this. You had enemies moving down when they got to the player. Oh no, the player doesn't know what to do, so he kind of gets destroyed. So that's perfectly fine. So let's go ahead and do the same thing for moving upwards. So if we're moving upwards, then we know we want to have it on case 1. So if we set our move type to be 1, well, in that situation, basically we want to use the same bit of code that we used here. So we'll copy all of this if statement. But now instead of when our X position goes below X target, instead of our velocity changing to move downwards, we want to change it so our movement is going upwards. So nice and simple, that's all we need to do. But we need to make sure that at the end of this case, we type in break, like that. And we'll go, oh, we got a bit, oh, that should be a semicolon, not a colon. There we go, we'll pop back into the game, let it play out here, and we'll hit play. Oh, we didn't change the movement type, I just realized. We'll actually just move him down the screen here so that we can see that. We'll go to our enemy. I've got a bit of an error up here and down here when you run the game, and that's related to how I set up the explosion effect in our previous video. I'm going to fix that up in a second, but we'll just sort this out first. So we got move type 1 to move him up. I'm going to press play, and we should see our enemy starts moving upwards as soon as he reaches that point in space. So I've got a bit of an error I'm just going to quickly fix. I set up an explosion for when our player shoots an enemy, but we've got an empty slot now on our enemy laser, so I'm just going to fill that in with an enemy explosion, even though our enemy lasers won't actually ever encounter that. But that's fine. So we've got our bit of movement in place. Down here then, we've got our third case, which will actually be oh no, this should be inside the curly bracket. I put down that a bit too far. So our third case, which will actually be case 2. So in this situation, what we're checking for is our player moves down to a certain point. So we'll still have it that we're checking to see if the player gets below a certain X target. So we're going to use that here. We're going to say if transform.position.x is less than our X target. Then we'll do a little bit of code here. But we also want to check if the player is at a certain position. So we're going to create a new variable here just below our X target. We're going to create a new public float Y target. And we're also going to add an extra step for allowing our players to be either moving towards this Y target up or Y target down. Now we could add an extra move type here, so we could have be second move type, but we're actually going to do, sorry, a fourth move type, which would be number 3. I don't know why second came into the case there, but what we're going to do instead, just to give us some variety and some extra options, we're going to add a public bool for move up. So what we're going to check down here now is say if move up, so if we're moving up, or if our ship should be moving up, well, in that situation we're going to check again if our ship, if our transform dot position dot y, if it's greater than where our y target is, so our y target on the map, well, if it's greater than our y target, then we want to stop moving up. So we'll say our rigid body dot velocity should be equal to new vector 2 minus move speed x, and we don't want it to keep moving up anymore, so we'll say 0f. Otherwise, if our transform dot position dot y is not greater than our y target, then we want to be having our rigid body velocity moving upwards. So instead of 0f, we'll have it going to move speed y, so it's pushing our ship upwards. So that's what's happening if our ship is moving up. But if our ship isn't moving up, well, that means it must be set to be moving down. So we'll do the exact opposite, but we'll copy that bit of code, we'll paste it in here, and we'll say, okay, check and see if our transform position is below our y target, because if our ship is going to move down, then its y target must be lower. So we'll say if it's below the y target, then we don't need to go down anymore, but if it's not, then we want its velocity to be pushing us downwards. So we'll say that, save that, and we have one final else to add in here, and this else is checking if we haven't made it as far as our x target yet. Well, in that case, then we should only be making our rigid body velocity move us to the left. So we'll say vector 2, and we'll just copy the rest of this little bit of code here like that. And then finally, we've come to the end of our case, so we can break out of it. So there we go. We'll save this, we'll go back into the game. Like I said, we could have just made that be case 2 and also case 3, but we wanted to vary it a little bit and make it a little bit more interesting. So we'll wait for that to compile, go to our enemy. Let's set our y target for this guy to be, we'll say he'll move towards a y position of 1 here, so he doesn't go all the way to the top of the screen. Actually no, we'll set it to be 2, so he's not quite in the middle. We want this one to move up, and we're going to set our move type to be move type 2. Oh, we had a bit of an issue there. Oh, what's happening is our our little guy here is running into its own laser, which obviously isn't very good, because when he's being instantiated, he's immediately firing his lasers at him. Oh, I just realized, no, he has a shot delay, so that's okay. Let's press play again. That was what was causing the error, because the lasers are destroying themselves. So that's going to be an issue that we're going to have to fix up. For the moment, what I'm going to do is I'm going to remove that enemy explosion that I had reset back into the game, and we're going to hit play, and we're going to fix up that little error in the next episode. So now we just can see our ship, it moves up to a certain point, and then he keeps flying off to the left, just the way we wanted him to. So now we've got some more interesting movements going on in the game, but we've got this bit of an error that's being caused by the fact that our enemy ships are somehow managing to be able to shoot themselves, which obviously that's not really what we want them to be doing. So let's take a look at how we can fix that in the game.
Konnichiwa.